Okay. We have a few minutes left, I guess. So, you guys, I want you guys to figure out actually the access to OpenStack, so you have reliable, connectivity in case we need it, and you have an understanding how to do it, but also get some experience in setting up instances in some sort of cloud services. And that's one of them, the one we have right now. You may need it in other papers anyway, but we may also need it for the third end of last assignment, basically. So it may be another thing we will ask you to do. But still, again, since we have those network access issues, we still need to think about how clever that idea really is. So something to figure out. So instead of going deep on or going into Docker right now, which we'll talk then next week about containers, which is because it's a very important concept for deployment, but also for developers. So for you guys, I want to show you a few AWS services, briefly introduce them and give you more of an appreciation what IaaS kind of means, right, in terms of complexity. So, and that's why this way. So again, we're not requiring you to sign up for it, at least not as of now, because you need to provide your credit card, which is kind of unfair-ish. But we're still looking at other ways of dealing with this. But anyway, you should have an overview and see how it kind of works and looks like. So, so you access it basically by accessing aws.amazon.com, as opposed to the conventional bookstore front page that you get. And then you need to, after obviously signing up, you sign in, and then you get something like this. So, cool. So the first and one of the important things to be aware of is that you work in particular zones or regions, right? So we see all services, we see tutorials, but if you go to the top right, you actually notice obviously your user account, but more than that, you actually see different regions you can operate in. So right now we are connected to US West, which is in the data center in Oregon. You can use the European one by just switching around. And the important thing here to note is that even though it all looks the same, you're actually operating on a different data center there at this stage. It also means that some data center may or may not have functionality that others provide. Yeah? And what's obviously an important concern regarding the data center choice? What are things to bear in mind there? Or why do we bother in particular?
Latency. Response time?
It's all about latency, isn't it? Right? So you look where the customer base is and you want to move it as close as possible to those. That's why you do it. Pricing can vary as well there. I think, at least it did. I'm not sure if it's still the case. So it's worthwhile thinking about this and bearing it in mind. It actually does vary, so yeah. So now we work in US and Oregon, let's say. Let's do it for this iteration right now. So that's the kind of set of services you get in Amazon by default. It's around 60 services or a bit more. I didn't bother counting them because they change nearly on a daily basis, so it's not really something you can easily keep track of. So, but the easiest way I think to just see them, it's kind of this view here. So you basically get a history of the services you accessed, but on the right you see the different service types. And again, it's good for us to get an intuitive feel what does actually do, what they mean. So they're grouped by their functionality. Main thing is processing or compute in Amazon lingo. So there are services there. Storage, something we talked about. Database solutions, and content delivery, networking, and then things like migration. That's obviously hot for you if you want to shift your in-house data to Amazon or the other way around, possibly. That's the way to do development environments. So you can have full development pipelines embedded in AWS. So you actually don't need to host anything locally. You can all keep it online. It's obviously very convenient if you have constant internet access, but other than that, reasonably mobile, and management tools as well. So if you're running your entire data center online, you probably also want to be able to actually monitor what you're doing. And along with this comes identity management as well. So you can also have an authentication service that is backed by Amazon. I think that's the default one here. That allows you to manage different users and users group that have access to your particular setup, to your particular project basically, and all the VMs that are included, and you can deal with roles, policies, and override them. So it's kind of a bit about introducing a hierarchy there. But anyway, we don't want to dig too deep in this one. I rather want to concentrate on some of the core services in those different categories. The obviously, I think most central one, for at least from my perspective, is and the one that is mostly representing the idea of infrastructure as a service, is the EC2 platform. So that's the I think nowadays most known functionality that they actually provide. And so we basically, yeah, shifting to that one right now. So basically, this is similar, or is it? Is it similar to what we see in OpenStack? Well, to some extent, but it's probably a bit more going on here. So, so that's the default EC2 overview. What do we have here? You can obviously have reports, limits, and so on, but the interesting bit is happening down here. That is the instances that you can manage. I just terminated an older instance. The images you're dealing with. Again, the block storage is different, or is separated from the VM instances, so you can manage volumes independently of this one. And we find something down here which we saw before, such as security groups. You can set up various security groups that are persistent. You keep them. For example, I configured this one here, which is about SSH. So again, you similar to what we did before. You modify the rules. In this case, I added rules to allow incoming HTTP traffic on port 80 and port 8080, the typical kind of application server ports like Tomcat and so on. They run on this one, and we do as well by default. And ports 22, for example. Obviously, you have default root with default settings which you're not supposed to touch anyway. The idea is there that hang on. Default rules. All traffic is allowed basically, which is kind of, so inbound traffic is limited, but outbound traffic is allowed. Very similar to what we had before. So cool. Then you manage your key pairs as well, and we have a notion of elastic IPs. And elastic IPs is a bit different from what we had as floating IP. Well, it's similar to floating IPs, but it's motivated from a different perspective. Every instance that you create here basically has a public IP, meaning it's directly accessible from the internet. Right? However, those IP in the default setup can actually change. So Amazon is free, or reserves that the option to actually just change the address at their discretion for whatever reason. But if you want to fix the address more or less permanently, you can do that by having those floating IPs. But bear in mind, for many of those services, you just pay on top of it, right? So it's all pay-per-use. It also implies all the features. Anything you use that you actually ultimately charged for. But just to show you the breadth of options they actually have, it's probably worthwhile launching an instance with those guys. So I just clicked on instances and then launch instance. And you have different AMIs, as they're called, as the Amazon machine images. So they have kind of become some sort of de facto standard as well. They're supported by other solutions as well in the meantime. And they're basically images of operating systems, which you can find freely browsable here. So it's a wide range of setups. So you find Windows, obviously, as well as various Linux flavors. So in fact, so many intricate variants here in Windows. For Windows, but similarly also for Linux. You find the Ubuntu server 1404, SUSE, and so on. So a minimal Linux AMI, which is or customized Linux for Amazon, for example. But they also have what's called the, you can create your own ones, but there's also marketplace. So you can actually use third-party AMIs as well. So you as a contributor could put your machine image up there and charge for it. So you get actually paid for, by someone else running your image. So again, it's an opportunity to do stuff there. So, and then there's community AMIs and so on. So again, this whole app concept is built into the system here as well, which you can use. But for our purpose, we just stick to one simple standard one, which you just bring up. Notice if you sign up, just before I forget, if you sign up for Amazon, you should get around 1 year of free execution time on EC2, unless you hit certain limits or thresholds and so on. But you want to obviously, perhaps you want to use that if you do, and notice that some of the EMC or the images have the tag free tier eligibility, and those are the ones that you don't need to pay on top. But if you take the more juicy ones or more advanced ones, such as the Windows 2016 Data Center Edition here, then you need to pay on top of what you, so you need to pay for it basically. So, but most of them are freely available, and you will be finding anything you need from there. So just pick one of them. And then, similar to what we saw before, we need to have an instant type, right? So in OpenStack it was called flavors, but the same thing here. If you look at it, the only key difference is that the selection is considerably larger than what you've probably found in OpenStack. And I have doubts that we make any effort to make up for this. So in this case, 46 CPUs, what is that? No, that's RAM, yes. 488 gigabyte of RAM max. You can have 8 2 terabyte SSDs if you like, so really fast, access basically, and so on. So, and then obviously network performance, so up to 25 gigabit connectivity. So it really scales to your needs, right? So depending on what you want to do, you really find your flavor here. The free tier doesn't allow us to instantiate machines with 25 gigs, so we just stick to the free tier, which is a moderate single CPU and 1 gigabyte. Looking at the different cloud services, having played around with this, I find that the most sensitive bit for pricing is RAM. So usually the price difference for one shifting or getting an additional CPU is generally cheaper than getting doubling your RAM, for example. So that's something to bear in mind. So we get 1 gig of RAM here, not too massive, but it should be enough for our purpose as well. So one instance, one network, use the default network. Again, we don't need to manage our own network by default. We can just be on the public internet immediately if you want. Obviously important to get your security groups right. Can be linked to a particular subnet. We want to auto-assign the IP address. Yes, that's right. Right, shutdown behavior. So that's quite interesting, but important to note. What happens if I shut down the machine? It may auto-terminate the instance. So that's quite useful if you want to do quick processing, for example, like data-intense tasks, and you want to terminate your instance afterwards. You just have a default selector on terminate, and it will just kill the machine once you're done. Cool, and monitoring, things like that. So followed by obviously attaching storage. So volumes or storage is managed separately from the actual processing instances, so it's not the same. Again, it's detached, similar like OpenStack, it's always the same pattern. And what you can actually pick is the size, but also thinking about performance. So if you need to have high throughput hard drives, you use various variants of SSDs or conventional magnetic drives, but it's all reflected in the price. Yeah, the slower you go, the cheaper it is. Again, worthwhile to be bearing that in mind. And should it be deleted on termination when the instance is deleted or not? It's the question. Recall that in OpenStack it's not done by default, so you would need to delete the volume separately. In this case here, it's linked. You can also obviously add further volumes. So if you want to have yet another one, you can link them as devices into your Linux instance and assign them different characteristics. For example, if you want to separate the system from a data partition, or you want to run a database in a dedicated volume, that's easily feasible there. So anyway, I'll just run one volume here right now. You can have tags, so you can simply relatively easily find your VMs. If you provide them with tags, it's easy to group them on that basis. Finally, or not quite finally, but nearly there, security group. I'll just pick this one here, so you can use existing one. And I think we're pretty much there. So it warns you if something is open to the world. In this case, we actually allow access to some things. Looks good so far. Did I see anything else? Cool. Yep. Finally, it asks you to obviously choose a pair and link against. since I have one pair available, I just use that one. It's very, very similar to what we did in OpenStack. So once you have set it up and you keep the private key pair, you can just use it flexibly. So it's quite straightforward at that stage. Cool, the instances are supposedly now launching. We'll see how that goes. And let's see. So it's running something here, so it's still initializing. But for example, just to show you, if you now go to a different data center, for example, London, you're actually operating on an entire different network, an entire different data center. So there's no instance here. There also, hang on, is my key pair is not here, the security groups are not the additional security groups have not been created, and so on. So it's an entirely different data center you're basically dealing with. Just for the, hang on, just for fun of it, spin up here one. Don't need to do much. Generally, clicking through is reasonably okay. I need to have an it doesn't even let me. I will need to create a pair. Sorry, I want to spin up an instance, see how it goes, but perhaps you get around this somehow. There you go. Proceed without a key pair. So it creates an instance there. So this is now in London, so we can probably just, I'm wondering if we can perhaps, once we get the IP address, it will be available here, IP public address, once it's set up. So the Oregon one should be, I think, running at this stage. Let's see. It's usually relatively fast. Yep, there you go. We have an IP address. Let's just see if we can ping this thing. 275. 166, 117, 95. Not quite ready. There you go. So now I bring up PuTTY. Again, we need to use that thing. I have a ready-made profile, but the IP address is off, so I need to fix that one. That's right, 166, 117, 95. See how far we get. Yeah, it's actually running. So, cool. All right. So yeah, so it's basically a running instance now in Oregon and the London one. So can I ping this thing actually, or can I not? Because I probably should have allowed pinging in security groups. Let's see if we can just quickly set that up. We want to have an additional rule that allows us to ICMP v4, so we have incoming requests from anywhere. So we are interested in IPv4. I just copy this thing, save. The outbound rules are permissible, so it should be fine. Let's go back to our instance. See how it goes. Cool. So what I did just now was enabling ICMP, which is basically a ping protocol, right? So by default it's blocked as well because it's a good way of doing denial of service attacks. So I just opened up that particular rule. So, but we get a feel now of what the performance is for the Oregon one. So that's in US to around 200 milliseconds. I think is a reasonable assumption we can make. Let's see if we can do the same for the London one. See what differences we. Any guesses what the differences are? Anyone? Any guesses? ICMP before, where is it? Yes, it's the right one. And then it's custom, anyone, anywhere. Good. And so setting up new security group. It's called ping right now. We need to attach that to the virtual machine, see if it's actually running. Instance. Instance settings. Change security groups, there you go. And we want to switch from that one to this one. So basically changing the rules of engagement here in a way sense. So, and I'm copying the public IP, and that should suffice to just test. Yeah. All right. So, okay. So you see considerable difference, right? So it's around 35 milliseconds as opposed to 200 roughly. So it kind of could make sense to optimize that for your particular use. But that's basically a rough idea here. Again, now you're free to run your service. You need to manage all different ports that you possibly want to run on your instance. So let's look at some other services, because I think you get the gist here of that one. You can also, interestingly, something that's worthwhile mentioning is perhaps you can take snapshots of your volume. So sometimes you want to try stuff, or you want to be safe as a kind of hard variant of backup in a way. You can take a snapshot of your current volume. So it's super easy for you to roll back in case something goes sideways. Yeah. So it's worthwhile. Also, you can name different volumes. So this is very handy, especially if you have multiple attached to a given instance. Are there any questions regarding this EC2 thing, or any thoughts or thoughts about features that you may have? No? Yep.
So for us as programmers,
yep.
Say I'm writing an actual
yep.
application for users, is it a good idea for me to be dabbling around in this with operation stuff I don't understand, instead of just using Heroku?
Yep, that's one option, but the motivation for showing you this one is firstly to understand, to appreciate what it is. I mean, dabbling around is one thing, but I think it's quite important. But I feel, or I fear, you can twist it any way you like, that sooner or later you guys will be more or less inclined to work in those environments as well, because Heroku has its limits. Yesterday we looked at the proposed or expected market development, and it's really clear that IaaS and SaaS are the ones that are going to stay in the long term, whereas those PaaS platforms are possibly going to be superseded. And I can tell you why, because AWS is basically PaaS as well. Right now we're looking at the lowest level, but I'll show you in a minute where we suddenly have platform as a service capability as well. So I think you will kind of be coerced in this greater in this kind of ecosystem that is not clearly, has this delineation no longer really well defined and clear. I agree. Hopefully you don't need to run that kind of stuff, but I think it's quite important to know what people are talking about when they talk about EC2 and AWS and S3 and services. Yeah, so that's why I'm running you through it. But I think there may be some people that, if you did some sort of running your own servers and so on, then you probably can relate to some of those aspects. Cool, but no, that's a valid concern, absolutely valid. So coming nearly to platform as a service, we have Amazon Lightsail. Lightsail is basically a simpler variant that's precisely for what you will be looking for, something that is less involved in terms of setup. Right now we were kind of overwhelmed by all the different configuration options and capabilities. Lightsail is basically a way of just getting something running for a fixed price. In EC2, everything is generally dynamic pricing, so the idea is there you pay for what you use. But here you can have a fixed subscription price, so it makes it very predictable, especially if you're a startup and don't have much money, to create your own instance and run something. So it's super straightforward. If any one of you has used DigitalOcean before, does anyone? You mentioned yes a bit. Yeah. Anyone else? They are very similar to that. So you relatively straightforward. Select what you want, ideally with applications on top or something like that. And then you just spin it up, basically. You select, again, your image, like how much RAM, how much CPU you need. But that's pretty much it. You bring it up. You pay a fixed price. There you go. So first month free, but that's precisely what you get. Notice here, again, that is very sensitive to, in my view, I find it very sensitive to the RAM here. So it's a considerable jump, particularly if you want to get 2 gig of RAM, which you often need for moderately sophisticated web services, or web servers rather. You end up with 2 gig of RAM. But again, that's it, right? So that's like one page, and you click away, and that's all you get basically, and all you need. So way simpler. So one version, if anyone wants to develop and have access to it. Another thing I want to show you is Elastic Beanstalk, and this is something that will remind you much more of Heroku. So here is literally about just saying what kind of development platform you want to be using, Golang, Java, whatever, right? So PHP, Node.js, and so on. And you basically can just basically launch an instance and then just submit your code basically to it. And basically it operates the same way as Heroku effectively. It provides you a URL, and that's what you want. So in this case, you may still use AWS, right? So it may still be an option for you guys, especially given the broad availability. That's one of the other services they provide. But apart from the computing bits, here's another one, Lambda. I'm not going deeply into that. So if you want to not write complete web applications, but only functions, for example, or very simple functionality, you can even do that. So you link data flow to only endpoint functions that you execute, for example, to calculate, I don't know, so an interest rate, or I don't know, loan calculation or whatever else. So you literally break down the application to function level as opposed to application level. Then AWS Lambda is your way to go. So you don't even think about application servers anymore at all in this particular context. So it's even, well, easy as the question, but the point is what you're doing here, you're buying totally into the infrastructure, because you need to link up various services that AWS provides and just attach your code functionality. But you don't really have much direct control, I would suggest, over the underlying infrastructure at all. So it's a classical PaaS kind of environment. So yeah, so basically you have functions that are kind of a fixed functionality that you can attach to your application or compose your application of. Those are the kind of things you can do here, if you want to explore that worthwhile. Batch processing is basically you want to number crunch large amount of data and want the system to do it automatically. That's something you can do there. Storage, S3 was the first product of AWS, by the way, they came up with. And that's something I just want to show you how that works. The idea is there that you can have buckets that are disconnected from any VM. So you just have storage, isolated storage, considered also part of the infrastructure. And let's come up with a host name that's reasonably unique. We host in US, and we create what is called a new bucket, and basically stores any object of any size. The cool thing about this, we can attach stuff like versioning, server access logging, object level logging and tags and so on. But I'll just start one instance here. The cool thing about the buckets is that it's considered or meant to be inherently reliable. So Amazon constantly monitors your buckets with respect to integrity and does duplication or replication across different sites as well, which is quite useful. You have this kind of bucket and you can use it for various purposes. For example, for distributing media. So if you have fixed static media you want to distribute, but also, for example, for what could we do? You could host a web page, for example. That's a service they, I think, offer as well. Go back. So if you have a simple, hang on, perhaps you find something. Index HTML, it should be a relatively smooth way of making that publicly accessible. We just leave that as it is for now. So I created a small bucket, NTNU is the bucket called, so that creates a page here. So now I should be able to make that public. And it's just the permission set, blah, blah, all that kind of stuff. Let's have a look on this thing. So, and this should be basically publicly available via this URL now. So what in the HTML is quite straightforward. I haven't shown that. That's just, yeah, well, I can show it here. Some HTML. But the point is you can host easily your own website without, again, thinking about the underlying infrastructure too much, but just in terms of data. You just dump it on the server, and your static config is distributed and you know, fast and highly available and reasonably safe. So something to think about. That's S3, so it's storage service. So, and they have different things of that nature. EFS, Elastic File System, is if you want to attach additional volumes to your servers, you can do that there. So you can define basically your additional external hard drive that you plug into services if you want to. So similar to what we saw before, but it's totally independent from a particular instance here. That's the key idea here. So you're, yeah, just defining where you want to run it, and then you can ultimately attach it to individual EC2 instances. What's another thing I want to talk about? Glacier is the archiving service. So if you want to do a long-term archiving of data, you can do that there. And the different database systems. So RDS is the Amazon own relational database systems, which you can use, again, high availability, but you buy into their own solution, so database solution. I'm not sure if you can back this with a database instance of your choice, such as MySQL, MariaDB, but they also have their own implementation that you can basically use, and so on. I mean, it goes on like that. You can have your virtual private cloud environment. I talked about monitoring service before. You can do routing as well. So if you need to manage your DNS domain, assuming you have a domain that you want to manage and introduce subdomains and hosts and so on, then you can do it here. So basically you would create a hosted zone for a domain that you hopefully own. Well, need to. So if you have a domain that you own, you can actually manage the DNS entries there. So more like system administration stuff, no doubt. But again, it can be then dynamically linked to an EC2 instance. So you run everything in one environment. Also, because you have different roles, you could have the developer working this thing. So using, for example, the high-level Beanstalk functionality, or you know, any sort of PaaS kind of functionality, and the low-level sysadmins as well. So that's the idea about a fully fledged cloud environment, that you manage all levels in one big environment, from infrastructure, platform, to software level. Because if you look here, Amazon also offers, well, admittedly simple, some desktop level kind of functionality that you can directly use, even from UIs potentially. So it doesn't necessarily need to require a lot of coding at all, rather than a bit of configuration. So yeah, so another advantage of this, using this whole mechanism, is that you have very refined analytics. So if you run all your entire infrastructure there, you can do basically, you monitor any access that's happening to your system, and that's obviously pretty powerful for you as from an analytical standpoint, and you know, to improve your system further or make it further available. Not to talk about things like artificial intelligence, IoT aspects. So there's constantly new services that are going to be introduced in AWS. But this is generally the same for Azure and Google Cloud Computing. So they have a similar feature set. I had a comparison page that I wanted to show you, because I put that also into the slide set in case you're interested. But it basically compares the functionality for all the different services, right? AWS, Google Compute, and Azure, and their products that they provide. For example, container support. We talk about containers next week. You know, app desktop service, object storage. So S3 is object storage, the one we just saw briefly. Block storage, which is hard drive. Backup options, content delivery network. So it's like you securing yourself on the one hand against possible DDoS attacks if you can, or at least improve the delivery of content, especially if you're providing media. Load balancing, administration, blah, blah, blah. So heaps of services, too much to cover in one lecture anyway, but hopefully enough to give you a brief overview of what it's all about. Sorry, I was a bit of a, rush through all the different services, or many of them. Any thoughts or questions regarding this? No? Who has no clue what's going on here? Yeah? Okay. To an extent that you can't relate it to cloud computing anymore, or to an extent that you're not sure what the individual services do?
Not sure what the individual
okay.
services do.
Right, that's fine. That's fine, because there's too many different components that are discussed. That's right. Because I went all across from storage to networking to computing to database, whatever. Right. So it's all across the board. But the idea is just to appreciate that it's not like a Roku where you basically run code and hope it works. But here to do everything, you run code, hope it works. You may run the machine that runs the code. You may develop an entire network, including the load balancing. So you're basically building your entire IT infrastructure and can simply manage it from any endpoint, your virtual organization in the widest sense. Yeah. So again, I don't want you to understand or appreciate all the different details, but I want you to realize, what is possible, in a wider sense, what infrastructure as a service can actually mean on a wider scale. So yeah, that's basically my message for the day here. No other questions, worries? Cool. Right, cool. So we leave it at that anyway. Next week we're looking at Docker briefly, so a bit of coding for you guys again, so you're getting excited. But until then, you should have enough coding to do for your assignment, hopefully. So that shouldn't actually keep you bored, hopefully. So we'll see about this. Cool. Thank you very much for today, for attending.